Hi all, I am here with my new video on chapter Chemical Periodicity. In this video, we will learn about the periodic table and characteristics of the elements. Periodic table by Dmitry Mendeleev and Lother Meyer. In 19th century, Dmitry Mendeleev and Lother Meyer produced, while working separately, a periodic table of elements in which elements with similar properties were located in the same vertical column. Using this table, Mendeleev was able to predict the properties of such then undiscovered elements germanium and gallium. Both Dmitry Mendeleev and Lother Meyer produced periodic tables of elements based on their atomic masses of the elements. This arrangement led to some problems as the atomic masses of the elements do not increase regularly. Periodic table by Henry Mosley. In the early 20th century, physicist Henry Mosley discovered that the periodic properties of the elements are functions of their atomic numbers. This is called now modern periodic law. This means that the periodic table should be arranged in order of increasing atomic numbers. The modern periodic table is consists of periods, which are the horizontal rows, and groups, which are the vertical columns. Periodic table by Henry Mosley. The periodic table given by Henry Mosley is consists of two parts, periods and groups. Periods are horizontal rows 1 to 7. Elements in the same period have the same number of occupied principal energy levels. Tells us the valence level of the elements. Groups are vertical columns 1 to 18, left to right. Elements within a group share similar properties. Similarities in the electron configuration of their valence levels, also called a group of chemical family. Metallic character. Approximately two-thirds of the elements in the periodic table are metals. Metallic elements have these certain unique properties. Luster means the mirror-like shine that reflects light well. Conductivity means the ability to transfer heat and electrons well. Malleability means the ability to be rolled or hammered into thin sheets. Ductility means the ability to be drawn into wire. Example: sodium, iron, and mercury. Non-metals. Non-metals are brittle in the solid phase, to lack luster, to have poor conductivities. Example: sulfur, helium, and bromine. Bromine is a liquid at room temperature. Semimetals or metalloids. Some elements have properties somewhat between metals and non-metals and called semimetals or metalloids. Example: boron, silicon, germanium, arsenic, antimony, and tellurium. The bold zigzag line in the periodic table separates the metallic elements from non-metallic elements. Atomic radius. If we think of an atom as having a roughly spherical shape, then its size is reported as radius. The radius of a free atom cannot be measured directly. We measure the atomic radius as a quantity called internuclear distance, which is defined as the distance between two adjacent atoms when they are closest together. The radius of an atom is equal to 1/2 of the internuclear distance. First, ionization energy. An electrically charged atom is called an ion. Neutral atoms can be charged in two ways: loss of electron, positively charged, or gain of electron, negatively charged. The first ionization energy, I1, measures the ease with which an atom loses its first electron. To remove an electron from an atom, an energy equal to first ionization energy must be added. The smaller the amount of energy needed, the more easily the electron is lost. The first ionization energy may be measured for a single atom, but it is more useful to measure first ionization energy for 1 mole of atoms. First ionization energy for metals and non-metals. If we imagine that first ionization energy for an element is 900 kJ per mole, it means that 900 kJ is required to remove 1 electron from each atom in 1 mole of atoms. First ionization energy of the representative elements ranges from 393 kJ per mole to 2081 kJ per mole. Metallic elements generally have low first ionization energies. They tend to lose electron more easily than non-metallic elements. Ionic radius. Radius of an ion is called ionic radius. When an atom loses an electron and forms positive ion, ionic radius is smaller than the atomic radius of parent atom. If an atom gains an electron and forms negative ion, ionic radius is larger than the atomic radius of the parent atom. For example, lithium atomic radius is 155 picometer, while lithium positive ion radius is 60 picometer. And second example is chlorine. Atomic radius of chlorine is 97 picometer, but negative chlorine ion radius is 181 picometer. Electronegativity. Electronegativity of an atom is measure of its ability to attract a pair of electrons when bonded to another atom. The higher the electronegativity, the more the atom attracts the shared pairs of electrons. Electronegativity range from a high 4.0 for fluorine atom to a low of 0.7 for francium. Electron affinity. Electron affinity measures the energy change that occurs when an atom gains an electron and forms a negative ion. The more energy released by the atom, the more stable it becomes when it gains an electron. In this case, electron affinity is reported as a negative number. In some atoms, the tendency to gain an electron is negligible, and the electron affinity is reported as zero. In general, non-metals gain electrons more easily than the metals. In our next video, we will learn about variation in behavior among the elements in periodic table. Please like and subscribe to watch my new videos. Bye bye for now.